to the next installment on Unit 1, which is all about density. This video should be pretty short because, density is density. There's really not much to talk about other than what the equation is and what it means. So, what is density? Well, density is the mass per unit volume of a sample of something that we have, or it's how compact the particles are in a solid, a liquid, or a gas. So I have a pug at home, if you didn't know, and I always say that my pug is super, super dense. He's a small dog, but he's very, very heavy. There's a lot of stuff crammed into a very small amount of space. He's very, very dense. As opposed to something that's not very dense, he wouldn't weigh a lot compared to his size. And that's what we mean by the mass per unit volume. There's a lot of stuff in a given amount of space. So here's two examples, two images right next to each other. So on the left-hand side, I have this cube and I have this other cube right next to it. We could assume that they're the same volume. They're taking up the same amount of space. However, the cube on the left, there's a lot more stuff crammed into that particular area. So because there's a lot more stuff, that particular sample is going to be heavier. And it's heavier because there's more mass. Those added particles add more mass per unit volume, which also means that these particles are packed really darn close together, as opposed to this cube over here on the right, where there's not a lot of stuff crammed into the area. There's a much lower mass per unit volume. So here you can actually see the space in between the particles. So comparing these two images, this one would have a much higher density, more mass per unit volume because there's more stuff crammed into that space. Whereas this one on the right would have a much lower density because there is less stuff crammed into that space. And we can calculate how dense an object is by using the equation density is equal to mass divided by volume. And the mass you can usually find on a scale and is given to you in units of grams. And the volume is going to be given to you in units of milliliters or centimeters cubed. Now, those two units are interchangeable. So milliliters and centimeters cubed mean the exact same thing. Now, mathematically speaking, because when I divide units of grams, which is the mass, divided by the volume, which is in units of milliliters or centimeters cubed, those units don't cancel out. So your final answer, the units for density, are in grams per milliliter or grams per centimeter cubed. Those will always be the units for density. Sometimes you might see other units for mass or other units of volume, but typically it's going to be either grams per milliliter or grams per centimeter cubed. One way that you can also solve for any one of those variables, because sometimes in problems, you're not just going to be asked to find the density. You might want to know the volume given the density and the mass of a sample. So I like to use this little triangle that one of my former students many years ago actually showed me. So I have a triangle with a T in that triangle, and notice it's DMV. And you can remember DMV because you're probably going to get your license soon and you want to go to the DMV. So DMV, straight across. Doom, doom, doom. If you're trying to find the density of an object, you want to cover up the density with your finger. Now, I can't do that on myself. I kind of did that with that mouse, but you want to cover up the density with your finger. And density, therefore, is equal to mass divided by volume, because it's mass over volume, which is essentially what this problem is showing you. However, you might not be asked to find the density. A problem might ask you, what's the mass of a sample given the density and the volume? If you use this triangle, you'll cover up the mass with your finger. So if you want to find mass, mass is equal to the density times the volume. So D times V, because they're next to each other in this triangle. If you want to find the volume of a sample, again, you would cover up volume. And volume is equal to the mass divided by the density, because it's mass over density. So rather than memorizing 3 different problems, you can either manipulate this one if you're mathematically inclined, which is great, or you can use this little triangle and really you have all 3 equations in one. D equals M over V, M equals D times V, or V equals M divided by D. Let's do some examples together. Sample problem 5. So let's just rewrite our equation down here. So if you remember, D equals M over V. Just so you're aware, mass is usually going to be given in units of grams. And you can always find that by using a scale in the back of the lab. I don't know why I wrote the whole thing out, but that's okay. There, that makes it a little bit better. Mass is in units of grams. Volume is going to be in units of milliliters or centimeters cubed. Those are interchangeable, they equal one another. So 1 milliliter equals 1 centimeter cubed, just so you remember that. And therefore, since you're taking grams divided by milliliters or grams divided by centimeters cubed, density is going to be in units of grams per milliliter or grams per centimeter cubed. It just depends on whatever unit your volume was given in. So just be aware of each of your units here. This first one, we're just going to use D equals M over V. We really don't need the triangle because we're solving for density. So sample problem 5. A sample of aluminum metal has a mass of 8.4 grams. The volume is 3.1 centimeters cubed. What is the density? So we want to find density here. This one's pretty easy because we're just going to plug in mass divided by volume. So D equals the mass, which is 8.4 grams, divided by the volume, which is 3.1 centimeters cubed. Now, those are interchangeable, so it's okay. We're just going to leave it the way it is. And when you solve that, you should get this crazy answer, 2.709677419. Holy moly, you do not have to write that whole entire thing out. We do want to use our significant figures. So this top number has 2 significant figures because it's a measurement. This bottom number also has 2 significant figures. So we want to round this answer. So it has 2 significant figures. Final answer would be 2.7, and don't forget your units. So because I literally took grams divided by centimeters, your answer would have units of grams per centimeter cubed. And that's how you do density. Let's try a couple more practice problems together. All right, so let's do some sample problems, or the practice problems rather. So it's just the next 4 that you can find in your notes. Before we get started, let's just go over that, that triangle again. So of course, if you want, you can always use the equation, density equals mass divided by volume. But I think it helps a lot of students to use this guy right here. So you would draw a little triangle, and you draw a T inside of there, and then you would write DMV, because again, you're probably wanting to go to the DMV to get your license at this point, so that's a good way to remember what order it goes in. If you want to calculate the density of a sample, what you would do is just cover up density with your finger, and you would see that D equals mass divided by volume, which is what I have here, M over V. Sometimes the question's not asking you to find the density, though. It wants you to find the mass or the volume, and sometimes students have a hard time figuring out what the other equation would be. So let's say we want to know how to calculate the volume of a sample. So I would cover up volume with my finger, And notice how volume is equal to mass divided by density, m over d. So in this case, V is equal to m over d. That's another way to express the density equation. It's just written a little bit differently. Sometimes you might want to find the mass of a sample. So in that case, using the triangle, you'll cover up m, and notice you have d times v, or d right next to v. So when you want to find the mass of a sample, mass is equal to density times volume. Mass equals density times volume. I think the triangle helps a lot of students kind of see how to solve for each of those, especially if you're not very good with algebra. You don't have to rearrange the equation at all. This allows for you to use that very nicely. Let's go ahead and dive in and try sample problem 1. What is the density of a block marble that occupies 310 centimeters cubed? So centimeters cubed. Now it's not saying specifically what unit that is or what variable that is, but because it has those units of centimeters cubed, we know that that must be the volume. So 310 centimeters cubed, and has a mass of 853 grams. So notice we do need to use this top equation here because we want to find the density. We have to take the mass divided by the volume, just to make sure that you're plugging your numbers in correctly. A lot of times students, they'll plug in the 310 over the 853, and that's incorrect because you always have to use the mass divided by the volume. So density is equal to 853 grams, the mass, divided by the volume. And when you plug that in your calculator, 853 divided by 310, you have a ridiculous answer, 2.751612. You have that long thing. Use your significant figures or dividing. So I have 3 significant figures here, 3 here. Your answer should also have 3. And don't forget units. And you could find your units right here. It's grams divided by centimeter cubed. Don't forget those. Those are really important. There's the answer to number 1. Number 2 says, a diamond has a density of 3.26. So in here I'm given the density. So already it's a little bit different than the 2 we've done previously. What is the mass? So mass is what I'm trying to find, of a diamond that has a volume of 0.351 centimeters cubed. So mass is what I'm trying to find here. So rather than racking your brain to try to figure out, oh my God, what do I do with these numbers? Use the triangle. So you'll see that if you want to find the mass, you have to multiply the density times the volume. So let's go ahead and do that. So M equals D times V. The density is 3.26 grams per centimeter cubed. Multiply that by the volume. And when you do that, with sig figs, I have 3 significant figures here, 3 significant figures here, which means my answer should also have 3. Answer is 1.14. The units for this, you can either remember, so okay, you solve for mass. Mass has to be in units of grams. Or, now I'm going to show you something, and if this confuses you, pretend I never even said it. But if I have grams per centimeter cubed times units of centimeters cubed, those 2 units cancel, and you're left with units of grams. So the units also work themselves out too. If you have no idea what I just said, just remember that mass should always be represented in units of grams, which is what we have right there. So sample problem 3 or practice problem 3. What is the volume? So we're trying to find volume here. We have not found this before. Of a sample of liquid mercury that has a mass of 76.2 grams, given that the density of mercury is 13.6 grams per milliliter. So, again, if you don't want to use the equation D equals M over V and cross multiply, or however you want to solve that algebra problem, you could see that if I want to find volume, go back to the triangle, volume is equal to the mass divided by the density. So let's write this down here. Volume is equal to mass divided by density. And just make sure you're plugging in the correct values for those. Sometimes people will plug in 13.6 on top, but 13.6 is the density, so it has to go on the bottom. 76.2 grams divided by 13.6 grams per milliliter. A milliliter, remember, is the exact same thing as a centimeter cubed. So it's okay if they're interchangeable. It's not going to change any of the math. Plug that in the calculator. And I have a ridiculous answer, but I have 3 sig figs. 3 sig figs. Let's round my answer to 3. Units for this. So it is the volume. Now, you could just remember that volume is always either in centimeters cubed or milliliters. So in this case, it has to be milliliters, just because that's what density was given in. However, you could also use the units to figure out what those units are. And I'm going to show you this again. And remember, if you have no idea what I'm talking about, skip ahead for this. But I'm going to show you why you get units of milliliters. So if I have units of grams divided by grams per milliliter, so you can't really divide fractions, but rather you multiply by the reciprocal. You might remember doing that in one of your math classes. So grams times the reciprocal of grams per milliliter is milliliters per gram. That's technically over 1. Those cancel out, and your units are going to be milliliters, which is why that final answer is in units of milliliters. In chemistry, it's always really important to have your units squared away. Now in Chem 1, you'll never have to do this, but I usually like to show students why the units are the way that they are. And mathematically, they work out just like math problems do. And let's try sample problem 4, practice problem 4. What I would recommend you do is you try this one, and I'm going to go through the work anyway so you could see if you have the correct answer. But this is a good thing about the YouTube videos is you could stop me mid-sentence and you could fast forward it just to see if you got the correct answer. If you didn't, you could always watch how I worked it out. So this YouTube is a great thing. Calculate the volume of a 26.5 gram solid. So that has to be the mass because it's in units of grams. 26.5 grams solid with a density of 7.48 grams per milliliter. So just like the last one, you use that little triangle, you would see that the volume, to find that, you'd have to take the mass divided by the density. So let's do that. Mass is 26.5. Divided by the density. Now this is the same thing as that, just so you're aware. It doesn't matter which way you write it, as long as you understand that those mean the same exact thing. My answer should have 3 significant figures. And because I was solving for volume here, notice my denominator unit for density is in milliliters. So that's the unit that I found right there. And there's my final answer. If you have any questions on any of these in your notes, put a little star next to them and ask me questions the next time you see me in class. Otherwise, we'll get some more practice with this, but that's doesn't get any more difficult than that. Density is D equals M over V, so not a complex topic. I hope this was useful, and I will see you in the next video on accuracy and precision.